Okay, I think it's time to start. Hi everyone, thank you all for coming. My name is Filip Rogaczewski. This is the first DevOps at which I'm speaking, so I'm a little bit nervous. I work for Spartes, where we partner with Atlassian on building some of the products that you all know, such as JIRA, Bitbucket, or HipChat. Right now, I lead a team which creates a cloud platform for third-party applications integration, but this is not what I'm going to talk about today. Today, I'm going to talk about my previous project, which was building of a completely new product in Scala. So, before I jump into the technical details, I'm going to quickly explain what is the corporate startup. We are becoming a bigger and bigger organization each year, but we don't want to become a dungeon. We still want to be innovative, and sometimes we are willing to accept risk in order to do what other big companies are unable to do. So out of our entire structure, we isolated once 2 developers, a PM and designer, and we sort of set them free. We let them take a risk. We let them innovate as much as they wanted to, and they were going after something not clearly defined, but something that can potentially open us for new markets. And they were able to release quickly, experiment a lot. They weren't bound by any process, and they had sort of a complete freedom of technological choice, but they had this existing customer base to whom they could sell our products. They still got salary, they got a cool office in the center of Sydney, and they got the best tools on the market. Unlike other startups, they didn't get 25%, and if they were going after these existing customers, their solution had to work on the existing platform. So our platform wasn't very controversial. We decided to give it a go with Scala, Soy, Backbone, and Spring, just because we already have 50,000 servers ready running these technologies. And we had we had a lot of success with Scala projects before. So these are only some of the projects which we developed in Scala, which is our file storage, which is our user and identity management, our Elasticsearch integration, service managing the pools of free servers that are quickly assigned to our new customers, and our marketplace is fully written in Scala as well. We have also developed some minor additions to our products in Scala, such as auditing or inline create, and we build our performance test infrastructure entirely in Scala. But we've never developed such a huge project in Scala before, so these are going to be some of the problems which we came across and some of the lessons learned which we found. So we knew already that Scala has a very good effect on the team morale. People like the fact that we got a more and simply a better we got a more expressive and a better language, and these functional concepts became very natural very quickly. We struggled at first with them, but later we learned that this is actually very natural because we've been all learning math for quite a while, and it didn't take us much time to learn how to do functional programming properly. We didn't find any strong correlation between language choice and the number of production incidents or bugs which we had, mostly because the bugs and production incidents which we have are usually derived from the integration between number of services, not from the code itself. So, short question is, did we succeed with the startup? Did we get any success with the project which we worked on? And the quick answer is yes, we did. Over these 2 years, we got many thousands of customers, and by customer I don't mean a single user, but I mean entire organizations which adopted ServiceDesk. We brought a lot of revenue to the company, and we have a lot of developers working on the project right now. But what's most important, we got a huge number of very happy customers who like the product which we provided them. So long time ago, before it became such a great commercial success, I went to Sydney to work on this project. Because of small layover in Abu Dhabi, it took me only 70 hours to get there. When I landed, it turned out that they lost my luggage. I had an engagement ring for my fiancée in the luggage. It was the worst idea which I had. Probably further on, I had only better ideas in my life. But anyway, I was quite optimistic about making the switch from Java to Scala, because I was quite confident that Java is not the language in which we are going to develop things in the future, and Scala is. And I was also quite happy about making the switch from Gdańsk to Sydney, because the view is amazing and it's warm all the time. And my first 3 minutes and 20 seconds with this project were amazing. I saw everything through pink glasses, until a second later, Maven came and ruined everything. This is the message which I got, and from now on, I thought that it's not going to be as good as I thought. So, most of you probably know this picture. This is one of the primary excuses of developers for slacking off. And this is not the way we want to work. We want to have a coding culture, not a compilation culture. Sven Peters is actually going to talk about the culture which we try to promote. We try to develop things fast. We want to ship a lot of good quality features to our customers. We don't want to spend our time compiling. And what's most important, when you're developing a new product, this is not the way you can work, because your competition don't spend as much time compiling as you do. And they have a better dev speed. As a result, they have a better, more feature-rich product. So to wrap this up a little bit, this is what we ended up with. Compilation time turned out to be a huge issue. When I started working on the project, it was 2 minutes and 30 seconds. A year later, when the project grew by 50,000 lines of code, we ended up compiling for more than 4 minutes. And that's a lot, with Zing and a number of Maven compiler settings which were recommended anywhere we could find. Similar Java project was compiled 4 times faster. We decided to try modularizing the project, and it helped us. But modularizing the project doesn't come without any cost. If you modularize the project, then you have to keep an API for the modules to communicate with each other. And you also have to have a separate deployment pipeline for this module. And basically, this wasn't our #1 priority to do at this moment. We had more important things to do than creating APIs for modules to communicate with and maintaining separate deployment pipelines. Fortunately, Scala 2.11 helped us. It got 10 to 15% faster. Unfortunately, we know that we can never expect Scala compilation time to be anywhere close to Java, simply because Scala has so many things to do that Java doesn't have to handle. And if we do some math, then it turns out that each day developer in the team spends an hour compiling. And if we had like 30 developers in the team, that would mean that 4 of them they are just sitting there and they are compiling. They are not delivering any features to the user. And we didn't have these issues with Java. So this was the conclusion that we came up with, that the compilation time for Scala sucks. But this wasn't the only problem which we had to face. It turned out very quickly that Scala doesn't play really well with the rest of our stack. Our stack was primarily Java-based, so our API was written in Java, and we had to convert everything back and forth. We had to convert JIRA Java API to Scala ServiceDesk internals. And then we got a number of utilities written in the company already. And in order to use these utilities, we had to convert the Scala ServiceDesk internal back to Java. So our REST utilities, they didn't understand Scala. And neither did Velocity or Soy, and JIRA, basically anywhere, was expecting Java input. And so did other projects with which we tried to integrate. And other issue which we had was that we have a marketplace, and you can build an application for JIRA or for ServiceDesk, and our marketplace is a huge business right now. Sadly, all our marketplace APIs had to be written in Java. And we ended up having a huge module for conversions. So this extended a bit further. We try to share as much code as it's possible with other teams in the company. We don't want each product to write its own authentication. We don't want each team to come up with its own user management. So we have to share the code between products, and when we end up having something cool, we want other teams to use this as well. And Scala actually restrained our code sharing abilities because Java teams were refusing to use libraries which had Scala APIs. We ended up having Java APIs for these modules. And it happened to us once when we were heavily behind the schedule that one team offered us help. This project was about scaling our product, and they were experts in this domain. Sadly, they didn't know Scala, so we ended up implementing this scaling feature ourselves. So one of the lessons which we learned is that you can't take a full advantage of the company stack if your company is Java-oriented and you're developing things in Scala. But we sort of learned how to live with this problem, unless we had to update to the next Scala version. So probably all of you here know semantic versioning. Semantic versioning basically say that you can release bug fixes, backwards compatible bug fixes with a patch release. You can release backwards compatible features during a minor release, and you're allowed to break API only during a major release. Unfortunately, that's not the case with Scala. Scala doesn't offer you this guarantee when it comes to API. API is broken during each minor release, and API, as it turned out, is also broken sometimes during bug fix releases. So this lack of binary compatibility caused us a lot of issues again. Because it turned out that when we wanted to update Scala library, we had to go over all the libraries and we had to update them as well. And if we were lucky, it turned out that the libraries which we were using are well maintained and they are released for this particular Scala version. But as the project was growing bigger and bigger, we weren't lucky all the time, and sometimes it turned out that we are using the library which is not actively maintained anymore. So what's the option right now? The option right now is to either fork the library, become the primary maintainers of this library, and lose a lot of our dev speed because we have to concentrate on things that we were not interested at all, or we have to put a lot of effort into rewriting these parts of code that are using this library. But meanwhile, when we were updating Java, we never had this problem before. Java libraries such as common slang were never broken for ages, and we can update Java without any issues, while we can't do the same for Scala. As I said, we can't, our marketplace APIs have to be Java. That's also for the API, lack of API compatibility. We are very strict about following semantic versioning for our API. We have a lot of third-party integration built on top of our products, and we don't want our API version to be driven by the version of Scala which we are using. So that would have to be in, these APIs would have to be written in Java anyway. Sadly, there is no promise from the Scala community that this is going to change one day. This is what I found on their website recently, is that if needed, there are going to be breaking changes. There are no breaking changes in other languages which we use except for Python, but that's at least a major release. So what we learned is that if the API is broken so frequently, we can't really trust it. And I would go a little bit further, and I would say that if you can't trust API, then that basically means that there is no API at all. And this issue with API had an effect on our memory usage. So I will explain you how our infrastructure looks like. We have 50,000 servers running JIRA, and each of the servers contain the same OSGi bundles. So only some of these bundles use Scala, and these bundles are maintained and delivered by separate teams, and we can never expect to change all these bundles at once because we love our release manager and we don't want to give him a heart attack. So that's okay. We will simply have to learn how to maintain few versions of Scala at once. And there is this OSGi feature that allows us to export Scala library with a particular version. It's very easy to do. It didn't turn out to be any problem, unless we did some math regarding the memory usage. If we have a look at the Scala library, it's quite small. It's okay. It's only 7 megabytes, and the recent one is 5 megabytes. That's acceptable. But then we want to use ScalaZ as well, and we have to use one version of ScalaZ for Scala to 11, and with a separate version of Scala for Scala to 10. And in total, it ends up to be quite a lot of memory. When we add everything, it turns out that by bundling all the Scala libraries, just a Scala library and ScalaZ, we have increased our memory usage by 2.5 terabytes. And we haven't delivered any feature yet. This is just plainly due to bundling Scala and ScalaZ. And I don't want to start thinking what's going to happen if we start supporting Scala 2.12 and ScalaZ with 2.12 as well in ScalaZ 7.0 and 7.1 for 2.12. This is going to raise by another 50% probably, or hopefully not if Scala gets a little bit smaller. So low memory footprint is our priority. And each library increases this number heavily because we have to support this library for multiple Scala versions. We know that we can decrease this number by applying a better multi-tenant architecture, but if we didn't have this problem with API compatibility, this number would be already half. We actually had to rewrite one project once because of its memory footprint, and this slowed us down heavily. On the related subject, any of you know what this number may mean in context of compilation and the number of anonymous classes which Scala produces? Scala produces so many anonymous classes and this is hopefully going to be changed soon. I heard that the next release might go out on the 1st of July, and this is going to feature a proper JDK8 support, but until it didn't a year ago when we came across this project, this problem. So we got so many classes that our project failed to compile due to an unknown reason. And we took like 2 engineers, it took them 2 or 3 hours debugging Java compiler, and we found out these 2 flags. They are very badly documented. You can Google for them for a long time and you are not going to find much. And it turned out that there are these compiler settings that let you handle all this huge Scala projects which you are about to compile. And this is not a problem right now, but we wasted a lot of time solving this problem, whereas our competition written in different language didn't have to solve these issues. But here comes a good thing. So debugging and tooling is getting better and better each year. And as we were developing the project, we saw that there was some great increase in the quality of these tools. They are getting better, but we are very spoiled by JetBrains. The Java tools provided by them are of such a fantastic quality that it's very difficult to switch to a different language. And we got very, very limited evaluate expressions for Scala, and stepping in would usually take us deeply to Scala library. What's good is that JProfiler and JRebel worked. We got out of memory exceptions sometimes because the stack trace got very, very deep. And we also got a support issue. We got a number of tools which were going through the logs and automatically recognizing what's happening. Sometimes these logs got so big that these tools weren't working anymore because they were simply not ready for Scala. They are ready for Scala right now, but we never anticipated this issue. And the issues were simply escalated to developers very, very quickly. So I told you about API breakages and about memory consumption, about the issue with compilation time and lack of code sharing capability with Java teams, but we also got some organizational problems. For instance, how many experienced Scala developers there are. How many of you have ever successfully completed a Scala project? Not so many, and we had this problem. So Scala right now is the 30th most popular programming language. That's a drop by 5 positions since March, but that's also much better than when we started the project. We want to grow fast. We are a new product and we want to bring as many developers as possible as when the project grows. And sadly, there are only few people with successful projects, with successful Scala projects in their CVs. And sadly, some of our recruiters didn't know Scala. So even when they found Scala expert, we didn't know how to assess whether that's an expert or not. So we had to narrow down our recruiters pool only to some people that got a very good Scala experience. There was also a bit of an issue that some of Java experts didn't want to become Scala newbies, and some experienced developers had a lot of distance to projects written in potentially unsuccessful language. I know people who were writing things in a language called OpenRoad. Try Googling OpenRoad today. You are going to find some amazing pictures from the desert in Utah or Australia, but you are not going to find any mention of the programming language. And some of the people who spent few years of their life developing things in exotic languages were afraid that Scala is going to become a language like that. I don't think it's the case, but it's difficult to explain to every person during a job interview that this language which the project is developed in might be successful in the future, because we actually have no idea ourselves. The bit of an issue is that if you have a look at the startup community, then most of the startups are developed in non-JVM languages. What's good is that university in Sydney teaches a lot of Haskell and graduates like Scala a lot. So hiring experienced people is difficult, but most of startups were actually developed by grads, right? Unfortunately, only few % of the startups were actually successful, and we want to do our best, and by our best I mean bringing in some experienced developer in order to be in this few %. But this is not all. Like, Scala also offered us some very unique set of problems which we rarely had to solve when we were developing things in Java. One of this problem I call Great Scala Wars, which we battled between 2013 and this year. And this was basically about how do we develop things in Scala. So Scala code often turns into poetry. I think that some of you could have heard this. And some people don't realize that writing a project is a collaboration effort, not a beauty competition. And community offers very few advices on how to do Scala effectively, and even when you have a look at these documents, then the quality of the documents is not anywhere close to effective Java, for instance. That's something which we haven't realized when we were developing smaller projects in Scala, is that when you develop a huge project in Scala, then you actually want to know how to do this effectively. Scala has a lot of features, and it's probably a little bit too many. Sometimes it's very difficult to navigate through all these features, and when we bring new people to the project, they struggle with learning and understanding some of the Scala concepts. It gets worse sometimes when you bring a new person to the project and he looks like this. He has no idea what he has just seen, and that's basically because Scala doesn't help him. You know that that's not a Scala Z operator, that's a standard Scala operator. Is there any of you who understand what it does? Oh, close. It's a standard Scala operator that concatenates two streams, and stream is basically a lazy list. So if you have a look in IDEA helps you with implicit. It would tell you that this does stream concatenation, but you don't know about this when you have a look at pull request, and you don't know about this when you try to Google this, because Google doesn't really help you with these symbols. This one is much easier. It basically adds key value pairs to the map, and this is my favorite. This one doesn't send you an email. This is called Scala Z tagging, and this is actually a very cool concept. I like it a lot. So this concept, well, I think it's derived from Haskell, and what it does, it allows you to tag an existing object with an additional trait. So you can take a user from an external service, for instance, verify that the user exists in your system, tag this, and the other layers of your application are safe that the user tagged with your trait, for instance, a service desk user, that the user already exists in your system. We had a huge argument about whether we want to use this or not, and we ended up using this at first. Later, we decided that we are going to actually remove this because a lot of people didn't understand what it does. Have you seen this map? So when I was still a C++ developer, I came across this map. And this map lets you navigate through lands of C++. It's very helpful, and I think we can create a similar one. So when you develop a project in Scala, you can get lost in traits and multiple inheritance forest. Or if it gets really bad, you can get stuck in implicit conversion swamp. And there is a thing that's supposed to help you. It's not called STL, it's Scala Z. It's actually helpful. And if you go a little bit south, you're going to find something that looks amazing, but it's not particularly useful. It's called Scala improvement process. There are a lot of cool ideas. Not all of them, unfortunately, are implemented. And if it gets really bad, then you will get to the place where programmers eat each other. And we were there, and we don't want to go back. So there is a good quote from Martin Fowler, which says that any fool can write code that computer can understand, but only good programmers write code that humans can understand. And we should remember about this whenever we have an argument about usage of some Scala features. If there are people on your team that don't understand the Scala features, then you are probably using a wrong feature. And this year, it actually got really bad. We've decided that after giving a try for 2 years, costs outweighed the benefits, and we won't be developing any new code in Scala in this particular project anymore. Yet I feel that this is a bit unfair for Scala, because we got this enormous number of projects that were completed successfully with Scala. No one complains about them. They run just perfectly. And these people are willing to start next project in Scala. So let's just wrap it quickly by having a look at what we learned about doing project in Scala. So we are probably looking for something like Scala ---- rather than Scala ++. You want to make the learning curve for new people coming to the project not as steep as possible, but very, very easy. You want ability to bring many people in the project, and then as the project matures and people learn Scala, you want to start bringing new features. But an important issue is also letting people actually learn Scala. So what we did, we have set up Scala user group in Sydney. A lot of people go to this group, they share the ideas, and they can actually learn how to do these things effectively. Nowadays, we know that some of the issues which I outlined, we caused ourselves, but we were never aware of these issues because no one have told us, and there were not such knowledge easily available in the internet. And we try to encourage people to go to the meetings, listen to people who have this good experience of how to write things in Scala successfully, and we try to talk during such events as well. You probably don't want to build a huge monolithic application, which is an addition to existing platform, but you want to write separate services in Scala. That was not something which we could have done few years ago. Right now our infrastructure is ready for this. Few years ago we couldn't have done this. And you are probably looking for REST API not in process integration. Just because Scala is another JVM language doesn't mean that it's actually going to work seamlessly with Java. And even if it does, then Java isn't going to work seamlessly with Scala. It's actually a huge pain to integrate a Java project with Scala library. And what's good to always remember is that instead of growing really big and making the application a huge monster, it's better to create a new service. Even if that costs us a little bit of a development effort to maintain these APIs and in order to maintain a separate deployment pipeline, then that's probably worth this. So thank you for coming and listening, and if there are any questions, I'd love to hear them. Yes? That depends on the project. I wouldn't build this big application in Scala again, not especially when it had to be written on top of existing platforms. So I wouldn't be writing another OSGi bundle basically in Scala if you happen to be working for a bank where you have to develop a new module that's going to live in this OSGi environment. You're probably not looking for Scala. If you can create a separate service that's going to do the same thing but on a separate JVM, then Scala is a good option for you. And it was a good option for us in a number of projects. Any more questions?
One question. How did you solve Scala to your management when you started with Scala?
Excuse me?
How did you solve to your management Scala in the first place?
We didn't have to sell this. Right now, we would have to probably sell this a little bit more actively than we had to do this 2 years ago. But 2 years ago, we were just free to decide that we are going to give it a try. And that's because we don't want to become a dungeon. So even if we have to fail, then we are going to at least give it a try and see if we can fail or if this is actually something that's bringing us a lot of possibilities. And back then, 2 years ago, we simply thought that Scala is what you want to develop your next project in, and no one was questioning this. We had a number of successes already.
Is it still the case? Do you still think Scala is the way to go?
I would be more reluctant to go with Scala, but as I said, it depends on the project. If I had to write a next microservice, I would give it a try with Scala. If I failed again, or we didn't actually fail because we delivered the application, it's being sold to a lot of customers. But if we came across such issues again, then I wouldn't definitely try again. But I think that for microservices, it does an excellent job. More questions? Okay.
How much projects are written in Java and in Scala?
It's difficult to say exactly. We do a lot of projects. Most of our big applications are written purely in Java, or except for this one, and except for HipChat as well, which is developed in Python. And Bitbucket, it's Python as well. So I would say that probably half of the projects are developed in Java, and one big project is fully Scala, and the other two maybe something else which I can't remind myself at the moment is in Python. But a lot of services, these integration services such as user management, Atlassian ID or Marketplace, they are developed in Scala. And I think that this part of our company that developed these projects is looking mostly at doing other things in Scala as well.
I have a question about some Scala concepts that occurred to you while you are developing. So let's say I started playing with Play Framework, and to me, as a Scala newbie, the concept of implicit my mind was blown where the stuff comes from. And did you find any, let's say, concepts while you were developing the project that you wouldn't use ever, even if you started a new Scala project?
Yeah, so that would be definitely implicit. And I don't think that anything else causes such a lot of confusion as implicits. I think that you have to also be more strict about using symbols, because you're going to at some point bring a new person to the project, and this person is going to see one line of the code where you have like 3 symbols that can be basically replaced with a method name. And when this person sees a method name, then you can make an assumption that he will at least know what it does. If there are symbols, then this makes it more difficult for people to understand. After a while, after like few months with a project, you get to understand all the symbols. They are not this difficult, but at first, for onboarding new people in the project and making them learn quickly how to develop things in Scala, you're probably not looking after using symbols as well. More questions?
So when you tell us that you would not use symbols anymore, that much symbols, doesn't that mean that you wouldn't use Scala set anymore, because Scala set contains of many symbols?
Yeah, Scala set is tricky, right? It contains also a lot of cool things like tagging, for instance, and I'm a bit disappointed that it's very difficult to. I don't know whether I can actually express tagging in a different way than using symbols. The same is disjunction, right? And there is this symbol that no one understands, and which is basically equivalent to some sort of either with a little bit of difference than either. Yeah. I would be very reluctant with bringing Scala Z to a new project for as long as people didn't understand the Scala core. Once they understood Scala core, you can start bringing Scala Z. And I think we brought Scala Z too early, basically, and this is what caused us a lot of pain.
Did you have any success with the Scala Z documentation? Because I remember that it was next to non-existent, and the symbols pretty much didn't have names. They were just symbols, and one was called fish, and other was rocket or TIE fighter, like stuff like that.
Yeah, we had this one amazing developer in our team that understood all of them. I don't know how he managed to do this, but he did, and he was our documentation. So it's always good to have an expert in the team. Other questions? Okay, there are no questions. Thank you all for coming. See you.